Hello, good morning, dear students. Welcome to Interactive Virtual Class Nagaland once again. So, students, we will continue with the same chapter, that is structure of the atom. So, in our yesterday's class, we have seen that an atom consists of protons and electrons, correct? So, in today's class, we will see how these protons and electrons are arranged in an atom. So, to study the structure of atom, different scientists brings up, okay, they brought up different atoms, different model of atoms. So we will see one by one, okay. So the first model of atom was brought up by J.J. Thomson, known as the Thomson's model of an atom. So let us see, okay, according to J.J. Thomson, what is the structure of the atom, okay. So according to Thomson's model of an atom, okay, there is a positively charged sphere called the protons and negatively charged sphere called the electron. Okay, so we have the positively charged sphere and negatively charged sphere. So according to Thomson, an atom consists of a positively charged sphere and the electrons are embedded in it. Okay, so this is the positively charged sphere. Okay, this is the positively charged sphere, and in this the electrons, the negatively charged sphere, are embedded in it. So let us see. Okay, so according to Thomson, the negative and positive charges are equal in magnitude, so the atom as a whole is electrically neutral. Okay, so let us see here. According to Thomson, this is what the atoms look like. This is the structure of the atom. This red sphere is the positively charged sphere, and these are the negatively charged sphere which are embedded in the positively charged sphere. Okay, so here we have some examples. Watermelon. Yes, we have this watermelon. Inside we see the small black seeds. So according to Thomson, okay, the structure of the atom looks like this. This outer part is the positively charged sphere, and the small black seeds are the negatively charged sphere. Okay, but Thomson's model of an atom does not have any experimental evidence. Okay, although Thomson was able to explain the neutrality of the atom, when the experiment was carried out using this model of atom, it cannot be proven. Okay, so it does not have any experimental evidences. So this is the first model of an atom given by J.J. Thomson. Alright students, we have one question. Please get your rough devices ready. The question is, according to Thomson's model of an atom, the atom consists of which of the following? Okay, I'm giving you 30 seconds for this question. Your time starts now. According to Thomson's model of an atom, the atom consists of option A solid sphere of positive charge, option B, a positively charged nucleus, option C, a nucleus surrounded by nucleus in definite orbits, option D, a nucleus containing protons and electrons randomly distributed in the atom. Yes, students? Alright, students. So according to Thomson's model of an atom, the atom consists of a solid sphere of a positive charge, and the negatively charged are embedded in it. So option A is the correct answer. Now, Ernest Rutherford, he brought up another model of an atom. Okay, in 1911, Ernest Rutherford, scientist from New Zealand, wanted to determine the structure of the atom experimentally. So this scientist, Ernest Rutherford, he was interested in knowing the structure of the atom. Okay, so in order to study the structure of the atom, he designed an experiment known as the Rutherford's alpha ray scattering experiment. Okay, so using this experiment, he brought up a model of an atom. So let us see. Okay, so for this experiment, the apparatus used were, the first is alpha ray source, which is a positively charged heavy particles Then the second apparatus used is thin gold foil. Okay, we know that gold is more malleable than any other metals, correct? So this Rutherford, he used this thin gold foil. He uses gold foil because he wanted as thin as possible. He wanted a sheet as thin as possible. So we have the thin gold foil here. Then the third is detecting screen. Okay, detecting screen. So the zinc sulfide screen was used as detecting screen. So these are the apparatus used in Rutherford's alpha ray scattering experiment. So let us see. Okay, in his experiment we have the alpha ray source. These alpha ray source are positively charged. Okay, they are positively charged particles, and there are, okay, doubly charged helium atoms. Okay, so when these alpha particles were made to fall on this thin gold foil, okay, let us see what we observe. Here we see that the alpha rays, some they are in straight line, they travel in straight line, some are deflected. Yes, students, some are deflected and some are non-deflected. Some rays, some of the alpha rays were rebounded. Yes, students, so this was what was observed in alpha ray scattering experiment by Rutherford. When when alpha rays was made to fall on this gold foil, he observed that some of the alpha rays travel in straight line, some of the alpha rays got deflected, and some of the alpha rays rebounded. Okay, so here this gold foil will be made of gold atoms, correct? So when alpha rays were made to fall on this, he saw that the alpha particles were scattered. Okay, the alpha particles were scattered. Yes, students, the alpha particles were scattered in different direction. Yes, students. So let us see here. When alpha rays falls on it, we see that some of the rays travels in straight line. Yes, students. Some of the rays were deflected. Yes. And some of the alpha rays rebounded. So this was what was observed in Rutherford experiment. Okay. When alpha rays from the alpha source was made to fall on this gold foil, some of the rays deflected, some rebound, and some traveled in straight line. Okay, so from this experiment, okay, Rutherford inferred that most of the fast moving alpha particles pass straight through the gold foil. Okay, he observed that most of the fast moving alpha particles pass straight through the gold foil. Then some of the alpha particles were deflected by the foil by small angles. Some of the alpha particles were deflected, and one out of every 12,000, okay, 12,000 alpha particles appeared to be rebound. So when we look at this, okay, most of the alpha particles travels in straight line, some were deflected, and one out of every 12,000 alpha particles appeared to be rebound. So this was the observation of Rutherford alpha ray scattering experiment. Okay, so here some of the alpha rays passing in straight line. Yes, most of the alpha rays pass through a straight line. So from this he inferred that most of the space inside the atom is empty. Now he also observed that some of the alpha rays got deflected. So from this he inferred that the positive charge of the atom occupies very little space. Okay. Then he also saw that some of the alpha rays got rebounded and retraced. So he inferred that all the positive charge and mass of the gold atom were concentrated in a very small volume within the atom. Okay, so this is what he inferred from his observation from the experiment. Alright students, before we proceed further, let us answer one more question. The question is Rutherford's scattering experiment is based on which of the following? I'm giving you 30 seconds for this question. Your time starts now. Rutherford's scattering experiment is based on option A is alpha particle scattering from gold foil, option B beta particle scattering from zinc foil, option C beta particle scattering from gold foil, and option D gamma ray scattering from aluminum foil. So which of the following option is the correct answer? Alright students, your time is up, and yes, very good. The correct answer is option A, that is alpha particle scattering from gold foil. Rutherford's scattering experiment is based on alpha particle scattering from gold foil. Alright students, let us proceed. So Rutherford, based on his observation, okay, from his experiment, the observation from his experiment, he proposed his assumptions through his atomic model. Okay, so according to Rutherford, okay, there is a nucleus, okay, which is positively charged, and the electrons revolve around the nucleus in a definite orbit. Okay, so this is what the structure of an atom looks like according to Rutherford. The electrons we have, and we have the proton which made up the nucleus. Okay, so according to Rutherford, okay, there is a positively charged center in an atom called the nucleus. Nearly all the mass of an atom resides in the nucleus. This is the nucleus. Then the electrons revolve around the nucleus in well-defined orbits. Okay, and the size of the nucleus is very small as compared to the size of the atom. So these are the assumptions, okay, proposed by Rutherford based on his experiment. There is a positively charged center in an atom called the nucleus. Nearly all the mass of an atom resides in the nucleus. The electrons revolve around the nucleus in well-defined orbits, and the size of the nucleus is very small as compared to the size of the atom. Drawbacks or limitations of Rutherford's atomic model of the atom. So let us see. So according to Rutherford, there is a positively charged nucleus, and the electrons revolve around the nucleus in well-defined orbits. Yes, students? So let us observe what happens when this continues. So here we see that the electron is moving closer and closer to nucleus. Yes, students, and finally it will fall into the nucleus and the atom disappear. Yes, students. So here, any charged particle in a circular orbit would undergo acceleration. Okay, and during acceleration, these charged particles would radiate energy. Okay, so here we see that this is a charged particle. Electron is a charged particle. It carries negative charge. So when it travels, it moves in circular motion. It will undergo acceleration. During acceleration, it would radiate energy. So this revolving electron would lose energy and finally fall into the nucleus. Okay, so if this were so, the atom should be highly unstable, and hence matter would not exist in the form that we know. Okay, so if we are to follow the Rutherford atomic model of the atoms will be very unstable. It will be highly unstable, and hence matter would not exist in the form that we know today. But we know that atoms are very stable. Yes, students. So here we see that the electrons in circular orbit will go closer and closer to nucleus and finally fall into the nucleus, and the atoms will disappear. So here, according to Rutherford's atomic model of the atom is highly unstable. But we know that atom is stable, correct? So Rutherford could not explain the stability of the atom. Okay, Rutherford could not explain the stability of the atom. He could not explain. This Rutherford's atomic model of the atom could not explain arrangement of electrons in an atom. And this Rutherford's atomic model of the atom could not explain why an electron revolves around the nucleus in an orbit. Okay, according to Rutherford's atomic model of the atom is highly unstable, but we know that atoms are highly stable. So Rutherford's atomic model of the atom could not explain the stability of the atom, arrangement of electrons in an atom, and why electron revolves around a nucleus in an orbit. Okay. Alright students, let us answer one more question. Please get your rough devices ready. The question is, which of the following is or are conclusions based on Rutherford's gold foil experiment? Giving you 30 seconds for this question. Your time starts now. Which of the following is or are conclusions based on Rutherford's gold foil experiment? Option A is the atom has small dense nucleus. Option B, the nucleus is positively charged. Option C, atom is mostly empty space. And option D, all of this. Alright students, so we have seen that according to Rutherford's atomic model of atom, the atom has a small dense nucleus, right? The nucleus is positively charged and atom is mostly empty space. So here the correct answer is option D, that is all of this. Okay, all of these are conclusions based on Rutherford's gold foil experiment. Alright students, we have another scientist here who brought up another model of atom. So in order to overcome the objections raised against Rutherford's model of the atom, Niels Bohr, a Danish physicist in 1913, proposed an atomic model. Okay, so Niels Bohr proposed another atomic model to overcome the objections raised against Rutherford models of the atom. So let us see Bohr's atomic model. So according to Bohr's atomic model, okay, we have here the positively charged nucleus and the electrons are revolving around the nucleus. So in atom, okay, according to Bohr's atomic model, in an atom, electrons revolve around the nucleus in definite circular paths called orbits or shells. Okay, so we have the nucleus here. And these are the orbits or shells through which the electrons revolve around the nucleus. So we have the nucleus and orbits. Okay, we have the nucleus, we have the orbits in which the electrons revolve around the nucleus. Now next point we have here is each shell of the atom is named by alphabets starting from K and subsequent letters L, M, N, O, P respectively. Okay, so the different orbits or shells in which the electrons revolve around the nucleus are named as K, L, M, N, O, P. Okay, and continues. So it is known as K shell, L shell, M shell, N shell, O shell, P shell respectively. So this is the atomic model, Bohr's atomic model. We have here the nucleus and we see that the electrons, these are the electrons, okay, the electrons are revolving around the nucleus in a orbit or shell known as the K, L, M, N, O, P shell. So we have another point. Electrons in each shell are associated with a definite amount of energy. Thus, shells are also called as energy levels. Okay, electrons in each shell, electrons in this shell, okay, and electrons in this shell are associated with definite amount of energy, and thus these shells, okay, these shells are also known as energy levels. So we have the orbits or the shells or energy levels. Okay, so here we see electrons revolving around the nucleus in different energy levels. Yes, students. Now, as the distance from the nucleus increases, energy of orbits increases. Okay, so here this orbit is nearest to the nucleus, so it has lower energy. Now as we move away, okay, farther away from the nucleus, the energy increases. Okay, so this is nearest to nucleus, so it has lower energy. This is farther away from nucleus, so this orbit or this shell has higher energy. Okay, so we see that orbits have different energy. The nearer to the nucleus, it will have lower energy. The farther away from the nucleus, this shell or orbits will have higher energy. The energy of an electron revolving around the nucleus in an orbit remains constant. Okay, therefore these orbits are also called as stationary states or stationary energy levels. Okay, so these orbits are known as shell or orbits or energy levels or stationary energy levels. Okay, alright students, before proceeding further, let us answer one more question. Please get your rough devices ready. According to Bohr's model of an atom, electrons revolve around the nucleus in which of the following? I'm giving you 25 seconds for this question. Your time starts now. According to Bohr's model of an atom, electrons revolve around the nucleus in option A, random orbits, option B, definite orbits or shells, option C, spiral paths, option D, multiple energy levels simultaneously. Yes, students? Alright students, your time is up, and yes, very good. The correct answer is option B, that is definite orbits or shells. We have seen that according to Bohr's model of an atom, there is a nucleus which is positively charged, and the electrons revolve around this nucleus in definite orbits or shells which has different energy. Okay, let us see more. So here we have the nucleus, and we see the electrons revolving at the nucleus in different orbits or different energy levels. Now we see one of the electrons moving from this energy level to this energy level, and these electrons move from this energy level to this energy level. So from here we see that one of the electrons move from higher energy level to lower energy level, and another electrons move from lower energy level to higher energy level. So let us see how this happens. Okay, so when an electron absorbs energy, it jumps from lower energy level to higher energy level. So this electron was here, but after absorbing energy, it moves to higher energy level. Okay, and when an electron jumps from higher energy level to lower energy level, energy is emitted. So this electron was here, it moves from higher energy level to lower energy level. So in this case, energy is emitted. Okay, so remember this students, when energy is emitted, electrons move from higher energy level to lower energy level, and when energy is absorbed, electrons move from lower energy level to higher energy level. Okay, so Bohr's model of atom. According to Bohr's model of atom, only certain orbits, okay, only certain special orbits known as discrete orbits of electrons are allowed inside the atom. Okay, we have these different levels here. We have different levels here. Between these also we have some space, but revolving of electrons around the nucleus in this space is not allowed. So only certain special orbits known as discrete orbits of electrons are allowed inside the atom. While revolving in discrete orbits, the electrons do not radiate energy. Okay, while revolving around the nucleus, the electrons does not radiate energy, but when an electron absorbs energy, it jumps from lower energy level to higher energy level, and when an electron jumps from higher energy level to lower energy level, energy is emitted. Okay. Alright students, we have one more question. Please get your rough devices ready. The question is, when electrons move from a lower energy level to higher energy level, energy is, which of the following? Okay, I'm giving you 30 seconds for this question. Your time starts now. So when an electron moves from a lower energy level to higher energy level, energy is option A is absorbed, option B is emitted, option C remains the same, option D none of the above. Yes, students. Alright, students, your time is up. Yes, we have discussed that when electrons move from a lower energy level to higher energy level, energy is absorbed. So option A is the correct answer. Okay, now when electrons jump from higher energy level to lower energy level, energy is emitted. So for this question, option A is the correct answer. Okay, when electrons move from a lower energy level to higher energy level, energy is absorbed. Okay, alright students, so we have discussed different models of atom by J.J. Thomson, by Rutherford, and by Bohr's model of atom. Yes students, so let us see. Okay, here we have hydrogen atoms. This is what the structure of hydrogen atoms look like. It has the nucleus, one proton and electrons revolving around the nucleus. So this is the structure of hydrogen. So mass of hydrogen atom is equal to 1 because it has one proton. Okay, so can we say, okay, here we have structures of helium atom. In helium atom we have two proton. Yes students, two proton in the nucleus. So in this case we have one proton, in this case we have two proton. So students, can we say that, okay, can we say that mass of helium atom is equal to 2 into mass of hydrogen atom? Yes students, we have one proton here, we have two proton here. So here mass of helium atom is equal to 2 into mass of hydrogen atom. Can we say this? Let us see. Okay, so in helium atoms we have two proton. Yes students, this is the structure of helium atom, and we see that there are two protons in the nucleus of the helium atom. So helium, this is helium. So let us see. So let us take two hydrogen atoms. So if we take two hydrogen atoms, then we will have two protons, correct? Because in one hydrogen atom we have one proton each in the nucleus. So two hydrogen atom means two proton. On the other side, if we take helium, helium has two proton. So even if we take only one helium atom, we still have two proton. So we have two proton, two proton. But when we look at this weighing scale, we see that helium is heavier than hydrogen atom, even though they both contain two proton each. Okay, so why is this so? It was found that mass of helium atom is greater than 2 into mass of hydrogen atom, although they both contain two protons. So where is this extra mass coming from? Okay, where is this extra mass coming from? Two hydrogen atom also have two protons, one helium atom has two protons, but their mass are not equal. So where is this extra mass coming from? Does atom contain any other particle other than proton in the nucleus? Okay, let us see. So this scientist known by the name James Chadwick, okay, in 1932 James Chadwick discovered the presence of neutral particles in nucleus. Okay, James Chadwick discovered the presence of neutral particles in nucleus. So this is the neutral particles which is present in the nucleus. It is present in the nucleus. It doesn't carry any charge. Okay, this neutral particles which is present in the nucleus does not carry any charge, and it is known by the name neutrons. Okay, so neutrons are also present in the nucleus along with the protons, but these neutrons are neutrally charged. They do not carry any charge, and these neutrons was discovered by James Chadwick. Okay, the mass of a neutron is nearly equal to that of a proton. Okay, the mass of a neutron is nearly equal to that of a proton, and this neutron is denoted by the small letter n. Okay, so this is how the neutrons was discovered. So here we see that atoms is made up of three subatomic particles known as called as the electron, proton and neutron. These are the three subatomic particles which makes up the atom. Okay, so let us see. Here we have the structure of atom. This is what it looks like. Okay, this is what the structure of an atom looks like. The proton and neutron makes up the nucleus. Okay, the proton and the nucleus makes up the nucleus, and the electrons revolve around this nucleus in a definite orbit. Okay, so this is the structure of atom. Now, the sum of masses of protons and neutrons present in the nucleus determines the mass of an atom. So, mass of an atom is determined by the protons, the masses of protons and neutrons present. Particles called neutrons. Okay, so the mass of an atom is equal to the sum of mass of proton and mass of neutron. Alright students, we have one more question. Please get your rough devices ready. The question is, neutrons are neutral particles present in the nucleus of an atom. I'm giving you 15 seconds for this question. Your time starts now. Yes students. Neutrons are neutral particles present in the nucleus. True or false? Option A is true, option B is false. Alright students, your time is up, and yes, very good, the correct answer is option A, that is true. Neutrons are neutral particles present in the nucleus of an atom. Alright students, so in today's class we have discussed about the different model of atom given by different scientists, right? The first model of atom we discussed was the Thomson's model of an atom. Yes students, we saw that according to Thomson's model of an atom, they have a positively charged sphere, and in this positively charged sphere, the negatively charged sphere are embedded in it. Yes students, like this. But this Thomson's model of an atom cannot be proven experimentally. Yes students, so it was rejected. Then the second model of atom we discussed is Ernest Rutherford model of an atom. Now Rutherford, in order to study the structure of an atom, he designed an experiment called as Rutherford's alpha ray scattering experiment. And based on this experiment, he proposed a model of an atom which says that the nucleus is the positively charged particle. Okay, the nucleus is the positively charged particle, and the electrons revolve around the nucleus in a well-defined orbit. Yes students, the electron revolve around the nucleus in well-defined orbit. But any charged particles moving in circular motion will undergo acceleration. Okay, now during acceleration, this electron will radiate energy. This revolving electron will lose energy and finally reach the nucleus. So then the atom will disappear, which makes the atom highly unstable. But we know that atoms are highly stable. So Rutherford's model of an atom could not explain the stability of an atom. right? It could not explain the position of the electrons in the atom, and it could not explain why electrons revolve around the nucleus. Okay, so again, in order to correct this, okay, in order to overcome these objections raised from the Rutherford model of an atom, Niels Bohr, okay, he proposed another model of an atom. Yes, and according to Bohr model of an atom, the nucleus is a positively charged, yes, and the electrons revolve around the nucleus in a well-defined, in a definite orbit. These orbits are also known as shells or energy levels or stationary energy levels, and it was named as K, L, M, and so on. Yes, students. Now, the electrons revolve around the nucleus in these orbits. According to Bohr model of an atom, the electrons does not radiate energy, okay, but it can jump from one energy level to another energy level. When it emits energy, when energy is emitted, the electrons jump from higher energy level to lower energy level, and when energy is absorbed, the electrons move from lower energy level to higher energy level. Okay, now again, when the conducted an experiment by measuring the mass of hydrogen atom and mass of helium atom, they found out that two hydrogen atom, although they contain two proton, and one helium atom contain two proton, the mass of these atoms, that is mass of two hydrogen atom, is not equal to mass of one helium atom. Yes, students, later they discovered that it is due to the presence of neutral particles present at the nucleus. Okay, it is known as the neutrons. So we have discussed that the structure of the atom is that in nucleus there is presence of positively charged particles and neutral particles known as the neutrons. These make up the nucleus, and the electrons revolve around this nucleus in a defined orbits. Okay, so this is what the structure of the atoms looks like. Okay. Alright, students, so we have seen that there are three subatomic particles in an atom. There are electron, which is negatively charged particle, proton, which is positively charged particle, and neutron, which is neutral. Okay, it does not carry any charge. Proton and neutron, they made up the nucleus of the atom, and electrons revolve around this nucleus. Okay, so we will discuss about the structure of different atoms in our next class. Okay, all right, students, so this leads us to the last question for today. Please get your rough devices ready and respond to this question. The question is, how do you feel about today's class? Option A is happy, option B is quite good, option C is satisfactory, and option D is confused. So I'm giving you 25 seconds for this question. Your time starts now. How do you feel about today's class? Kindly give your feedback about today's class. Alright, students, your time is up. Thank you so much for your response, and thank you for joining today's class. I will see you again in our next class. Till then, take care everyone and have a nice day.